We are making our way through here. Rule 3, derivative of a constant multiple function. So that's where our original has a constant out front multiplied. So y equals k x to the n, for instance. Our derivative, y prime, we're going to keep the constant multiple k. We'll bring down our power and subtract 1 for the new power. So literally it's the same thing as rule 2, and the only difference is if you have a constant out front, keep it. You can't get rid of it, keep it. Okay, let's look at this one. We have y equals 3x to the fourth. I don't have to rewrite anything here like I did on the other examples because I don't have anything in the denominator or under a root, so I'm good to just take the derivative. This rule says if you have a constant, keep it. So I'm going to keep the 3, and then I'm going to take the derivative of x to the fourth as normal. So bring down the 4 and raise x to the new power. 4 minus 1 is 3. And, you know, you guys are brilliant, and that's why you're in this class. You're probably not going to take this step. After a little bit, you can multiply things in your head. So you could definitely just say, well, keep the 3, bring down the 4. 3 times 4 is just going to be 12. And then raise x to the new power. 4 minus 1 is 3. So you don't have to take this step. You can multiply it in your head, and we'll normally do that. But for these first couple, I'm just showing you without multiplying it in your head. This next one, I have a root, which means I have to rewrite it. So I'm just going to write an equals here. I'm going to keep the 6 and raise x to what fraction? It's the power, which is 2, over the root, which is 3. X to the 2/3. And now I'm ready to take the derivative. F prime of x. I'm going to keep the 6 because we always keep the constant multiple. And we're going to bring down our power, which is 2/3. X to the what? I have to subtract fractions again. I'm going to do it off to the side. I have 2/3 minus 1. Well, let's not write minus 1 because it's not really helpful. We need to change it to be the same denominator as our first fraction. So we wrote minus 1 as 2 over 2. Here we're going to write minus 1 as 3 over 3. 2/3 minus 1 is the same thing as 2/3 minus 3/3. So we're going to have 2 minus 3, which is negative 1/3. And you could check in your calculator if you didn't know if you were doing it right or not. And you could just leave it like this. This one's harder to multiply than the last one, but you're also welcome to multiply it because we're going to be plugging it in the application, so we might want to get used to multiplying it. So 6 times 2 is 12, divided by 3 is 4, and you could use your calculator. 6 times 2/3 is 4, x to the negative 1/3. Whichever answer is totally fine. Now, I would recommend if it's easy, multiply it. If it's not easy to multiply, probably just don't multiply it because you don't want to make a mistake on something that you didn't even have to do. Okay. So the next example we have of this constant multiple is the derivative of 5x. So I'm going to take the derivative of g, so I'll call it g prime of x. And I'm going to keep the constant multiple, which is 5, and bring down my power. What's the power if it's not written? It's 1. So it's really 5x to 1. So I'm going to bring down the 1 and raise x to what? What's 1 minus 1? It's 0. Well, what is anything to the 0 power? Please don't say 0. I know everybody wants to. Try it in your calculator if you don't remember. What's 5 to the 0? Or 50 to the 0. What happens if you raise something to the 0? You get 1. So this really ends up being 5 times 1, which is 5. So we get kind of a mini rule here. Your textbook doesn't have it, but I think it's just easier to know this rule than to not. The derivative of 5x is 5. The derivative of 10x would be 10. Derivative of 13x would be 13. We have a mini rule that says if you just have y equals kx, if you just have x to the first power, the derivative of that, you're going to keep the constant multiple k, bring down the power, which is 1, and then k times 1 is going to stay k, and then you raise x to the 0 now, which is also 1. So the derivative of kx is k. Derivative of 5x is 5. Derivative of kx is k. We can do some extra examples here. If we had f of x is negative 3.4x the derivative would be negative 3.4. Because you bring down your power, which is 1, and then you have x to the 0, which is also 1. So negative 3.4 times 1 is going to say negative 3.4. Just to really drive it home for you, let's do one more. Y equals 1,640x. The derivative of 1,640x is going to be 1,640. Okay, our mini rule. So try this one. What's the derivative of 902x then? It's going to be called h prime of x because it was called h in the original. Derivative of 902x is 902. Okay, so constant multiple, keep it, still bring down your power, subtract them for the new power. Unless the power is just a regular x to the first, then the derivative of like 16x is just 16.